Well, hello everyone, and this is the concluding session of our third day of the Blockchain Community Day conference. But this session is not a regular one, and it's a workshop. And today, together with Oleg Klimenko, who is my colleague at EPAM, and he's a lead software engineer, we will be hosting a workshop on building blockchain indexer using Polkadot and Substrate. And without further ado, I'm just going to ask you to leave any questions in the live chats wherever you are watching it, and we'll come back to all the questions at the end of this session. And Oleg, hi, how are you?
Hi, Alik. Hi, guys. It's my pleasure to be here. Thank you.
Yes, thank you. And I think we can hear you well, we can see you well, and the presentation too. Yeah, just click this hide button. Yes, and we are good to start. Yeah, good luck.
Thank you, guys. So today I will be talking about and showing, of course, because it's a workshop about Polkadot ecosystem, and it is an ecosystem. And my focus will be on practical things, practical from hands-on experience, and practical from integration these enterprises, because I think it's one of the next major hype thing to make blockchain be used inside enterprises. So my name is Oleg Klimenko. I'm a blockchain architect and hands-on developer, which is important, I think. And overall, I have more than 15 years in architecture and development. And I'm this blockchain for the last 5 years, and I'm doing Polkadot projects for last 3 years. Let's start this Polkadot overview. What is it? Well, I will be talking today about three main topics about Polkadot in general, about practical experience, hands-on experience, and about indexing, and by means of indexing, how to integrate Polkadot into existing systems of our enterprise. So, what's Polkadot? I think this is interesting. It was interesting for me how it's organized and why it's successful as an ecosystem. First of all, it has a coin. Its name is Dot, and they have a console. They have several managing units. One of the units is console. It's responsible for proposals, and of course, only quite rich guys could be members of this console. And this council is re-elected each 7 days, consisting of 13 members. Polkadot ecosystems has a technical committee. It's teams responsible for bug fixing, for updates, for allouts, and Polkadot also has treasury funds to make everything running smoothly. So Polkadot is able to communicate with Bitcoin and Ethereum. That's important because this communication ability is built in within architecture. I will explain it a little bit later. And Kusama network is a canary network for Polkadot. That means it not only provides test coins for participants, it also experimental platform space for all new features. So all latest experimental features could be found here. Polkadot uses proof of stake consensus approach. Actually, it's slightly modified, but classical is like this. We have validator role. It sends its money, stakes tokens, to participate in the consensus. Once it's participated, it receives rewards for its work. It's a classical thing, but Polkadot uses nominated proof of stake. It's like elections in the United States. Like we have not only validators, we also have nominators. Nominators select validators to do actual work. How is it done? So I will be brief here to explain this change in Polkadot. So nominators should have some money, which should have some dot coins, dot tokens. They reserve this token to elect validators, and validators accumulate all this token to do actual work inside blockchain. Once work is done, of course, not all validators are selected, not all nominators are selected. There is some algorithm involved. But once they are selected, they do actual work to inside blockchain, to validate blocks, to finalize blocks, things like this. And validators receive fixed amount of it's not reward, it's a commission. Validator receive commission, and nominators receive reward proportionally to the original stake. All this cycle is repeated each era. Era is usually 4 hours and sometimes 24 hours, depending on the configuration. So why Polkadot? Again, just reminding you, this is a review of Polkadot. This is just for to have common context and practical things to start soon. What about architecture? This is the main thing, and all the consequences of or how it could be used are there in the architecture. So we have main chain. Named relay chain. It's responsible for communication between other chains working in parallel. Here it is. So this is parallelization embedded into architecture from scratch. So relay chain provides parachain support. Parachain support is like virtual processor to communicate to the work, actually, not only to communicate, to the work of these parallel blockchains. Parallel blockchains, they are named like they have name is parachain. So all these parachains are working in parallel. This relay chain is responsible for synchronization, for single state, and for single security of all their ecosystem. So it syncs all the work. There is a lightweight thing named parathread. So small works could be external work could be done also in parallel by relay chain. What is this parallelism for? This parathread, parachain, this parachain could run blockchains in parallel, could communicate with other blockchains like Ethereum, Bitcoin. It could run and to communicate with off-chain workers. So different kinds of things could happen in parallel with main chain work. So that's the architecture. That's important because all the consequences are derived from the architecture. So Polkadot has interoperability, so different blockchains could communicate with each other by means of, for example, events. Scalability, we could add additional parachains. So it's scaled up to, main chain is scaled up to some. They are changing the rules, but up to 100 parallel working parachains. And I mentioned these, they have shared security. So all these security is managed and in sync by relay chain. Substrate, what's Substrate? Substrate, when we are close into development, First thing we know this word Substrate. This is framework to build these parallel blockchains, parachains. It's modular, flexible, and extensible. Extensible, that's important because uh, smart contracts quite limited in their abilities to, they are in a sandbox. So once you start to do something more than smart contracts to integrate these enterprise, you should create your extension, your module, uh, and that's a way integrate to integrate with enterprise. Frame. Frame is a framework inside the inside the blockchain to create runtimes. In other words, runtime. Runtime means a node, a version of a node, and it could be customized because we use palettes. Palettes is a module. This is a module inside Polkadot, and it could be addressed using these macros. So we are getting closer to actual hands-on experience. So using Substrate frame palettes, existing one, we are combining composing runtime. Runtime is again is a version of your node, so it could be not in order not to consume computer resource to be more manageable and consume less binary deliverable. We are composing each time different runtime, different version. I'm talking about my custom blockchain using Substrate framework. How to build it? We are building it using models. We are collecting the models I need. Okay. It's important also to, before we go deep into practical things, to understand architecture. Substrate framework. Substrate parachain has its own architecture. First of all, Rust language. Rust, one of their most loved language to learn by developers, according to some research. It's really interesting. It's hard to learn, and everything is in Rust internally in Substrate. Runtime, application logic. Smart contracts also should be run in Rust in Polkadot. There are other languages supported, but most essential way to use to create blockchain smart contract for Substrate is Rust. Only quite native libraries for network communication and API, they are written in they are specific to platform. WASM is such a great thing. It's coming everywhere in blockchain now because it is compiled version into some intermediate format, compiled, and it could be sent in Polkadot and Substrate to work in blockchain. And the blockchain could be updated without stopping any node. So no hard forking is needed in Substrate and in Polkadot. That's one of the key features here. Grandpa is a finalization engine is also one of main things in Substrate architecture. Let's start to do some practical things. Okay. So I've already mentioned about Rust, quite an interesting language, but one warning here, it contains more, it requires more effort from developers to learn because it's a kind of tricky language, but it's worth it to run. Let's take a look. I prepared several GitHub repositories. First of all, what we are starting with, this is a Substrate contract node. Let's take a look into this repository. So I've already done this preparation step. So I'm sharing links in this presentation. So I'm just encouraging you to do things manually by your hands. To build a local node locally, there are instructions. And of course, you will need to install Rust language and Rust ecosystem too. Once it's installed, you will see like you will have like this structure. You will see different logs into your console like these. Pay attention. Each and every node into the Substrate and the Polkadot environment, it uses database, ParityDB or RockstarDB. And this is important because I will be demonstrating Indexer, and Indexer directly connects to your local folder to fetch all the data. How does it work? Let's come back to the presentation. It works like this. So I'm running a local node, and I'm running it now. Local node synchronizes all the information from mainnet. I'm sure I connected to Kusama mainnet, and I use this indexer. Again, it's available by link. It's up and running now. Indexer using this location from running local node, which connected to mainnet. It fetches all the data in PostgreSQL relational database, and let's take a look. So this relational database has a structure. It has a structure, tables like these. So we have tables for blocks, for transactions named extrinsics in Polkadot, for metadata and things like this. This is already something. So once I have these tables up and running, this indexer up and running, I could navigate through tables and see what's going on. But for my case, for indexing case, it's I just performed some research and figure out that I could track some calls of smart contracts into extrinsics. So meta information is available in this table. Okay, I thought I made this thing up and running. So, yep, just this extrinsics. Then I parsed this format. It occurred to be a JSON format like this. And what I'm trying to do here right now, I'm trying to understand this format. And this format, I found calls to transfer method, to transfer amounts in a smart contract. And I understood that this is a JSON in binary format, and this indexer stores JSON in binary format. So that means I should be able to work with this JSON to extract payload. So in the game, using this JSON path up to account ID, source ID, and destination ID, I understood this. These calls, these trace means we are sending money. We are sending money from source to destination some amount of money, and this is happening in mainnet. Do you understand, guys? So all this table, this is money transfer in mainnet, and I'm able to track it, and I'm able to analyze it. How to do so? Again, for example, I'm just interested in extracting all the sources and all the destinations. I've just done it using some path for JSON to extract source and destination accounts. They are not personal, of course, but again, it's and I thought, why not to engage graph database? Graph database is an interesting thing because, because it's another view what's happening, and exactly this is the view. This is the view I got after this source and destination transfers. Only the fact that it was transferred. For the first like several hundreds of transfers, I put this from relational database by means of small utility, a small Rust program, standalone one I created. So now I'm able to view the transfers. This is my account, which sends or receives data. And again, even using this information, I can track something is interesting happening here. Two accounts are sending out a lot of individual transactions. Well, if it would be a real data, not test network like QSAM, I would say this is a fraud. I just able to spot this fraud because just a couple of accounts disbursing a lot of money payments, probably avoiding to be tracked for huge payments. But in Kusama, that means we work with initial distributors of money. So these accounts just sends by request test tokens to everyone. Again, why I'm doing this? This is integration. This is the indexer, and this is a way to integrate my blockchain, and this is a demonstration how could it be done to what's important for enterprise? They want to work with data in traditional ways. They have systems working in traditional ways, like relational databases, relational storage, relational formats, and JSON format. And I've just added more or less new graph database, and already I've got some interesting result. How did I again, what's the use case? What the use case for enterprise? And we are using it right now. We are starting insurance project, and it looks like this. Our organization, we are installing our local node, blockchain node. Blockchain node connects to blockchain to mainnet. It synchronizes all the data in background, and we are working. For example, we have an insurance case, for example, in healthcare, and traditionally we were building like synchronous and asynchronous integration, custom one. What's going on for each case? Now we could communicate with healthcare insurance case like this single entity. inside my local blockchain, but it propagates all of their changes to all other organizations, and hospitals are able to see what's happening in this insurance case, and insurance carriers are able to work and change the rules. What are they ready to pay for this particular health insurance case? And some pharmacy are working with the same view but installed locally to make their own workflow under the same insurance case. And this is distributed insurance case. It is the same between all the organizations. But what we need to do, of course, we could, and we are calling smart contracts here. But for our well, guys working inside other systems, traditional systems, we need to extract this information from blockchain. That's why this indexer is needed for, to extract this information and to do something meaningful for enterprise. That's really important thing. Again, the instructions how to make it up and running. I create a fork and running it locally right now. They are located here in my repository. You could clone it. You could use this instruction how to make it up and running. It's not so easy, not so hard, not so easy. It requires some patience. Again, you should switch to RocksDB. This indexer works only with RocksDB. That's important. Once it's syncing, it will show you this kind of log. So sync is in progress, and you will see data in your database, your Postgres database. Once it's there, you could analyze it like I did, for example, and to work at this data. The data is fixed. The structure of tables is fixed. But it's you won't have access to storage. Storage is well, it's encoded. Locally, I believe it's possible to configure your local blockchain to be able to decrypt this data from storage too, if it's needed. But publicly now, only meta information is publicly available. But again, even public information, this is perfectly possible to do. Several words about graph database. So graph database is quite a powerful thing. I will be able to extract to import vertices and well, edges and links between the edges, like here, in a simple CSV format. So I exported it from PostgreSQL to GraphDB. Probably no, not right now, but yeah. Okay, it was just a CSV format. One thing to mention, it's using different queries like match. I'm showing everything, and I could restrict by this query. For example, I would like to continue my analysis and to show only accounts which have relations more than 50 relations. This is also possible to do. So some shift of developers' mindset is needed, but again, it's worth to do. Okay, this is one thing for enterprise to set up indexer to work with indexer data. Another thing Another thing is observability. Once you're integrating your local node into your organization, it's important you rely on its work. You should make sure it's working stable. How to do so? Again, we have a tools. In my repository for contract node, I created instruction how to make observability up and running using Prometheus and Grafana. It's contained into the same repository. Just one thing. I use macOS, so my setup for observability is for macOS or Linux-based systems, but it could be easily migrated to Windows if needed, if you know some basic commands of Docker. Once a node is started, it's available out of the box. Some of you guys who worked in the enterprises know this format. This is Prometheus metrics. It's available for each and every node out of the box for Substrate framework, at least if you not turn it off. And it's exposed by a working node, by blockchain. So again, using my instructions, I make up and running Prometheus and Grafana. Besides regular metrics, now I'm able to work with Substrate metrics. It's available here. So like this, and also I have I have found, actually I have not built it by myself, some template to work with Substrate, the dashboard template for Substrate. It works over Prometheus, and Prometheus fetches data from blockchain local node. That's how it works. Again, those are instructions in my repository how to make it up and running. I'm just showing you the end result. Okay, this is important for second thing after indexer, which is important for enterprise, for practical work within enterprises with blockchain. One more thing, probably one of the last. This is how do we interact with our blockchain node, because okay, besides indexing and things like this, we would like to interact with it using some UI and to work with contracts. So here is a front-end template. It looks like this. What's possible to do here? Just to select different accounts. This is test node, so I have a lot of tokens. To track balances, not a few, but we could upgrade runtime. That means, do you remember, this is quite important thing to upgrade. This is this one. So if I decide to create my own module named palettes in terms of Substrate, I could update runtime using this tool without any downtime, just using compiled version of my WASM, and to send it to blockchain, it will be updated. I could work with different accounts here, send money, and I could work with not only smart contracts, but Substrate allows some blockchain logic to be resided in runtime, not only in smart contract, but in runtime. So I could call these functions residing in runtime. Why I'm doing so? Because Runtime has more abilities, more functional abilities than smart contracts. Again, everything is written in Rust. So I encourage you to make it up and running locally with Link front-end template. And to communicate and to work with to deploy smart contract, usually this tool is used Polkadot.js. It's like this. Unfortunately, it doesn't work with current version of. It works with Polkadot, but it not 100% compatible with Substrate. So my local blockchain, which I built now, is not compatible. Again, I fixed this problem. I fixed this issue. So this fix is available here. It's forked from main repository, and I made some fixes. So now it's possible to upload to work with tool. By the way, magically, it's hosted in internet, but it works with my local node, and of course, it's possible to work with in each and every other mainnets. Okay, so again, my fix, and guys, please use it if you will try to work with it. Now it's possible to upload smart contracts to communicate with smart contract. I'm doing it exactly this, uploading and working with invoking methods of smart contract. So those tools really needed to work with Substrate. Just don't forget it exists and use it. Okay, so just to recap, I'm just almost done my talking and demonstration. Of course, it's quite detailed. Well, I think it's okay for now to discuss it at that level. So to recap, Polkadot ecosystem is really powerful. And it's still evolving and it's still developing. It could be used locally. It could be used as a private network, or we could use it. We could connect our network, try to connect it to mainnets. I mean, I encourage you to run Polkadot node locally, upload contract to work with these tools, to work with these fixes I've just shown to you. And of course, indexing is important almost in every enterprise integration, because just to invoke in smart contract is not enough for enterprises. Enterprises want to have history, to have batch interaction with intersystem communication, batch intersystem communication, not only event-based, not only call of smart contracts. That's basically it, guys. And thank you. I'm waiting for your questions.
Okay, so thank you so much, Oleg, for your interesting and such an insightful presentation and workshop. I think there is not that many content about this topic on the internet, and it's definitely one of the most useful ones at our conference. And I hope most of the audience will watch it in the recording on our YouTube channel.
Yeah, unfortunately, a lot of links, guys. So it requires some home task, huge home task. So this is not well, ready to use things. It's up to you to start using.
Okay. Yes, and we'll definitely send all of this link as a guide whenever somebody asks about this topic. And we don't have that many questions so far.
That's good.
By the end of this day, since it's kind of late in most of the countries who are watching this,
Mhm.
but it's early morning in America, right?
Yeah, it's like 8
So,
a.m., 9 a.m., 9 a.m. already.
Maybe, yeah, could you please maybe let me know how long does it take to learn all of this?
Yeah, it's a good question. Or actually, a good question. To make a local node up and running, well, the challenge is open source. Everything is open source, right? So we have different components here in the ecosystem. Rust framework, and they have built a tool named Cargo, and everything has its own version. Rust has its own version, Cargo has its own version, and sometimes it's incompatible. And once you download a node, it also has its own version, and sometimes it works only with a specific version of Rust and Cargo. So that's the challenge. But usually, well, instruction usually simple. It's just do on official site Substrate, build your own node. It's searchable. It's like 1 to 3 5 for 5, but 2 or 3 days usually it takes to make for developer to make something to start a node to start to create a simple smart contract and to interact 2 or 3 days just to warm up to. Of course, you won't learn Rust in this during this time. You won't learn smart contract development, but you will be able to understand structure of smart contract for Polkadot and some basics of Rust, simple things. Yeah, several days.
Okay, and I see a question about, so which sounds like, how does the indexing process handle complex data structures such as nested or custom types in the blockchain network?
It Simple answer: it doesn't, because indexer just put this data in a encrypted format, and it's up to you to decrypt it. So indexer is just a pipeline, like it should be.
Okay, and the final one, what approaches can be taken to optimize the performance and scalability of the blockchain indexer, considering the potential growth of the Polkadot network?
That's a good thing. Well, besides uh, besides in this indexer, I would offer to listen for events. It's possible to do to create your own. Well, everything is custom, so in this case, you should create your own indexer based on events, or you should learn how this indexer works. So besides it's really fast. My hard disk was full within couple of hours of working this indexer with QSAM network. So I didn't experience slowness, well, issue. I experienced, well, storage issue with this index. It's really fast. It's like crazy thing. But again, if you would like to do something more and you're not happy with current performance, it's a custom thing. Development is needed.
Okay, so looking forward to see something on this topic in the future, and I would like to thank you, Oleg, and thanks to all the audience who came here today. And I would like to remind that tomorrow at the same place, same time, we will be back with the first day of our conference, and tomorrow's lineup will be dedicated to the topic of NFTs and metaverse. And speaking about the metaverses, you may have already heard that we've got our own metaverse with this NFT art created by Arseny Vesnian. And before we go, I mean, after we disappear from this stage, you will see a short 2 or 3 minute video from the curator of that metaverse, Arseny Vesnian, inviting you to this. Uh, Metaverse gallery, which is dedicated to artificial AI generated art. Okay, then, yeah, thank you once again. Thank you, Alec. Have a nice day and
Thank you, guys.
cheers. Yeah, stay tuned. Bye
Bye.
bye.
Cheers.